Okay, we are continuing a topic from yesterday. Now remember what we talked about yesterday is we said, okay, when I take the square root of a perfect square, I just have this fact memorized, right? The square root of 169 is 13. The square root of 16 is 4. This is just a memorized fact. That's how I take a square root of a perfect square. These are the perfect squares, 16, 25, 64, 196. When I take the square roots of non-perfect squares, I can estimate like this. But these decimals are they're close. They're estimates, right? But this number, square root of 27, is not actually 5.2. It's like 5 point something, 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 something forever, right? So these are estimates. They're like okay for certain purposes, but these are like not great to use if we actually want to like do math with a number and be accurate. So then our next option is to simplify, okay? And here are our examples from yesterday. If we look at something like square root of 50, what we're deciding is, okay, what perfect square times any other number equals 50? Well, 25 is a perfect square. 25 times 2 is 50, and we know that the square root of 25 is 5. So this is amazing when it works. Like when we can think of like, oh, I know a perfect square that multiplies to 700, it's 100. This is great. But sometimes we just can't think of the right number, okay? So this is still skill number 2, simplifying. Okay, it's a continuation of yesterday's notes, but this time we're going to do it the long way. And the thing is the long way works. It works every time. It works even if you can't think of the numbers. So kind of nice to have this to fall back on if you aren't able to think of the numbers the other way, right? So here are, we're going to say like how to do it. Okay, and then we're going to put some examples. Okay, so here's how we're going to do it. The first thing you're going to do is you're going to prime factor. Okay, and my first example is going to be the number 72. Okay, now I want to be clear, you can do this the short way. The skill that you learned yesterday is not gone. It can be used. It's just tricky with some numbers, and so we want to have another option. So I'm going to take this number, I'm going to prime factor it. So what does that look like? I'm going to think of two numbers that multiply to 72. I'm going to think of 8 and 9. Neither of these are prime, so I'm going to keep factoring. 8 can be 4 times 2. 2 is prime, I'm going to circle it. 4 is not prime, I can keep factoring. Okay, I have prime factored this number. That is the first step in the long way, okay? Now, here is what's going to happen. I'm going to write out the prime factorization. And remember, it's square root of 72. So when I prime factor it, I'm going to write out all the prime factors, but they're going to be under a square root sign. Now, what I'm going to do is I'm going to put all the 2's together. And I'm going to put all the 3's together, right? And whatever numbers you have, like if you have 2 of one number, you'll just put them next to each other. Ideally, you put them in from least to greatest. It doesn't really super matter though. Okay, now, what's going to happen is that the numbers that are doubles are going to simplify. You'll see why. And the singles, the numbers that are not doubles, any other numbers, they won't simplify. Those are the ones that we can't simplify, right? Like remember yesterday, when we were doing our examples, here, the square root of 25 simplifies. It becomes the number 5. The square root of 2, it doesn't simplify. There's nothing that we can do to simplify the number 2. So that part doesn't simplify. Here, square root of 9 is a perfect square. 9 simplifies. The square root of 3, that doesn't simplify, right? So there's always going to be a part that does simplify and a part that doesn't. So watch what I'm going to do. I'm going to take, look, this is a double, okay? I'm going to put it in its own square root sign. Oh, look, this is a single. Why? Because these 2's were already a double, so then this 2 is by itself. Look, these 3's, those are a double. There's 2 of them. Okay, I'm going to put those in their own, this square root sign is called a radical sign. So I'm going to put my own radical on each double. And then look, the single gets its own radical sign. Okay, so everything got put in its own radical sign. If I had more than one single, like let's say I had a 2 and there was also a 5 in here, I would have put both of those in this one radical sign. Okay, so now let's see what happens. Look, 2 times 2 is 4. What's the square root of 4? Because look, 4 is a perfect square. So the square root of 4 is just the number 2. So all of this just became the number 2. This is, 3 times 3 is 9. 9 is a perfect square. The square root of 9 is 3. Look, this does not simplify. The square root of 2, what's the square root of 2? Nothing. It's an ugly, ugly decimal. Okay, there's nothing we can do to simplify this. But 2 times 3 is 6. And then this part doesn't simplify, 6 root 2. Okay? Now, the magical short way of doing this would have been to realize, oh, 72, that's 36 times 2. And the square root of 36 is 6, right? But realistically, we don't look at 72 and think, ah, yes, 36 times 2, right? Like, we just don't necessarily think of that. So in this case, we do it in a way that's longer, but gets us the correct answer, okay? Let's try one more. Let's try the square root of 90. Okay. Now look, here, you might think to yourself, oh, 9 times 10, right? And here's the thing, like, look, right, see how here right away I had a 9. In an ideal world, right here, you'd catch yourself and say, oh, 9, that's a perfect square. And you would just catch yourself here and be like, oh yeah, square root of 90, that's just the square root of 9 times square root of 10, okay? The thing is here, let's say you had caught yourself here, and you said, oh, that's the square root of 9 times the square root of 8. And then you might have thought, oh, it's just 3 root 8. The problem is that it's actually, like, the square root of 8 you can still simplify, right? Because 8 is 4 times 2. So then look, and this is exactly the same as I got. This would be 3 times 2 times the square root of 2. Okay, so you can see there's like a lot of different kind of pathways. The long way will always just get you there, okay? But the short way is just trickier, you know, you gotta pay more attention. So if you get to this point, you just realize, oh, 9 times 10, done, I'm just gonna do it the short way, that's fine. But if you wanna continue on, you would get 3 and 3, and 5 and 2, okay? So then my doubles are, look, and I'm just gonna put them in order. Okay, and I have a double 3, and then these are singles. So look, I'm going to put my double 3 in one radical sign, and I'm going to put my singles in the other radical sign. Okay, now look, this becomes the square root of 9, which simplifies to 3. This becomes the square root of 10, which does not simplify. It doesn't matter that there's 2 numbers in here. They're not double, so this is not a perfect square. This is not 16 or 25. The square root of 10 is not 5, okay? It's just, it's can't be simplified, and this is the answer. Okay, now again, right here when you factored, you could have caught, like, oh, that's, right, this is just the square root of 9 times the square root of 10. You could have started right away with this and just realized it was this, okay? But it's tricky because, right, like, then you have to ask yourself, oh, like, can this be simplified, right? Sometimes it can, sometimes it can't. The long way will always work, though.